Okay, today we won't really learn anything new in 5.7. We're just going to make the problems get a little bit more complicated. So what we want to remember from yesterday is that if we have a to the 2/3, that would be the cubed root of a squared. So the top number is the exponent and the bottom number is the root number. And then we have to simplify these. So once you know that rule, then you got to go backwards with all the other rules you know about radicals and exponents. All right, number 1, no letter. So you technically could do this problem in your calculator. So you could type 1 divided by 81 caret 1/2 and get the answer. Anytime there's no letters, you can see if it works in your calculator. If it gives you a decimal, then you must do it by hand. So how would you do this problem by hand? Well, what does 1/2 mean as an exponent? It means the square root of 1 over 81. And then we remember that we can separate those to the square root of 1 over the square root of 81. The square root of 1 is 1, and the square root of 81 is 9. So the answer is 1/9. So when you do it on your calculator, you're going to get a decimal. See if it'll turn into a fraction. They won't all be that easy. So looking at number 2, we're going to multiply. So we're going to add the exponents. Okay? The 5 times the 2 would give you 10. Oops, sorry about that. And then we would have x to the 1/2 plus 1/3. So grab your calculator and type in what's 1/2 plus 1/3. Get a decimal, you got to change it to a fraction. You get 5/6. So we have 10x to the 5/6. Now I want all of your answers written as radicals, not as rational exponents. So that would be 10 times the 6th root of x to the 5th. Notice the 10 doesn't go on the inside. This rational exponent is only on the x. Then you got to make sure it's reduced. Does 6 go into 5? No, so no x's can come out. Again, you notice that up here as well when you know that the 5 on the top is smaller. So that would be our final answer. So we're applying all the rules we have together now. Okay? Remember, you only can add these exponents if they have the same base. So they don't have the same base. But we should notice that these x's are the same. So when you're dividing, what do you do with the exponents? You subtract the exponents. So in this problem, one way to do it is to say that we have x to the 5/2 minus 1/2, which is x to the 4/2, which is x squared. So since it's a positive, it belongs on the top. So we have x squared on the top, we have y to the 2/3 on the top, and we have 2 on the bottom. Now remember, we took care of this x to the 1/2 when we did the subtraction. Well, I can't leave my answers in rational exponents, so we need to write that as x squared times the cube root of y squared all over 2. Again, check and make sure. Does 3 go into 2? No. We don't have any radicals in the bottom, so you're done. So all you're doing is applying your rules. Number 4. This is power to power, so we're going to multiply our exponents. 1/2 times 9/2 is 9/4. These 2's would cancel, the 3 would cancel, and we're going to get -3 on the B, and then 9/8 on the C. So these two, the A and the C, are still both radicals, but they're not the same because they don't have the same denominator. So we're going to want to make those have the same denominator. So we'll make the denominator 8. So this would be A to the 18 over 8, because I multiplied by 2. This is going to be c to the 9 over 8. And I missed the b because it has a negative exponent, so it belongs on the bottom. Change them into radicals. The 8th root of a to the 18th, c to the 9th, all over b to the 3rd. Is it reduced? No. 8 goes into 18 twice, so 2 a's come out. 8 goes into 9 once, so a c comes out. Then we have leftover. If you put it in there twice, you use 16. So you have 2 left, and then 8 takes away 8 of them, so you have 1 c left, all over b to the 3rd. And that would be our final answer. So we're just applying our exponent rules. All right, number 5. In this problem, we have a square root and we have a cubed root, and we know that those don't ever go together. We also should notice we don't have any letters. So it's possible that you would just type this on your calculator and see if it works out. Okay, if it doesn't work out, you would get a decimal that doesn't change to a fraction. So I'm going to show you how to do it without your calculator. There are several ways. First, you might notice that this is the square root of 5 squared. 2 goes into 2 once. 3 goes into 2, it doesn't. So that cannot be reduced, so all you could do here is change that into 25. That's what 5 squared is. So that would be the simplest way to do that problem. Okay, other people would say, well, I don't want to, maybe they don't notice this, that this 5 comes out. One way you could think about it is let's change it back into fraction form so it looks like this one, because that's the way we've started all the other problems. So that's 5 to the 1/2 and 5 to the 2/3. Then maybe you would want to say, well, you got to get a common denominator, so it would be 6. So that would be 3/6, and this would be 4/6. Now they're the same base, so you can add the exponents. 3/6 plus 4/6 is 7/6. Now you'd notice that one of the 5's is going to come out because the 7 is bigger than the 6. So one of them comes out, and one of them is left underneath here. Now the question is the cubed root of 25 the same thing as the 6th root of 5? Okay, so you would want to check that on your calculator and see if those are the same decimal. And then those would be the same answer, because neither of those can be reduced farther. Probably the blue method is the fastest and easiest way. All right, number 6. Number 6 seems to be a problem that people will make very difficult when it's actually very easy. You're going to use your calculator. You should notice that all of these have the same base. So all of our exponent rules will apply. So on the top, what should we do? We should add the exponents. So use your calculator. What's 1/3 plus -4/5? Change it into a fraction. You get a to the -7/15 all over a to the -7/3. Now we want to subtract the exponents. So this -7/15 is still in your calculator. So just hit minus -7/3, change it into a fraction, and you get a to the 28/15. It's positive, so it's on the top. If it were negative, you'd put it on the bottom, and then you'd have more work to do. So that's the 15th root of a to the 28th. Well, 15 goes into 28 one time and leaves us with 13 left over for our final answer. Now some people have started to skip this step because they've noticed that 15 goes into 28 once, and then there would be 13 left over. That's fine if you're skipping that little middle step there. All right, so we will practice some more of these in class, and that is it for 5.7.